So Chris, what is the point of this trip?
Well, the point of this trip is basalt.
Basalt?
Pahoehoe and Aa. Basalt. Basalt.
Basalt. Yes! It smells like rotten eggs.
This is Iceland. From the rivers, glaciers, rocks and waterfalls, Iceland is like no place you've ever seen. Ross Mitchell and I came to Iceland to collect sediment from the beaches and rivers around the island. But we couldn't help but stop at the spectacular geologic features all around us. So this is classic basalt. Basalt is a igneous rock that was erupted onto the surface, flowed down the hillside, and then solidified. Basalt is low silica. It has lots of iron and it has lots of magnesium, which gives it this dark color. You can see this basalt flow has these very interesting shapes that often, or I guess you could say, look like columns. We call this columnar basalt. Now, these columns form after the basalt lava flow is emplaced and then cools relatively rapidly. And as it cools, the basalt contracts, forming these fractures that then, if you were looking from above, you would see a polygon. And so this columnar basalt tells us not only something about the nature of the lava flow, the thickness of the lava flow, but also how quickly this lava flow cooled. This is a great example of one of these basaltic columns in cross-section, where you can see 1, 2, 3, 4, 5, 6 sides. And so this column used to go up in the same way that these other ones have, and then as they cooled, the columns pulled away from each other, creating these fractures in between each one of these columns. And this column has subsequently then fallen over, and we can see pieces of it around the area. And while in cross-section, you can see the columnar jointing, on the top of the flows, other spectacular features are visible. This is a phenomenal example of a Pahoehoe lava flow here in Iceland. There are two basic types of basaltic lava flows. There's Pahoehoe and there's Aa. And Pahoehoe is a Hawaiian word which means ropey. Now, the difference between Pahoehoe and Aa lava flows is the amount of water in the lava. The Pahoehoe lava flows do not have very much water at all, and so they flow very smooth across the surface. And Aa lava flows have more water, and that water degasses and breaks up the lava flow as it's moving across the surface, forming a much more blocky lava flow. These subaerial lava flows were amazing to see, but things get even more interesting when lava erupts underwater.
Almost all of Iceland is lava extruded and erupted above ground. Here we have behind us what are called, no joke, pillow lavas. I wonder why.
Are you comfy?
Relatively. These lavas, same basaltic composition as most of Iceland, were extruded underwater. When lava gets extruded underwater, it comes out in a tubular-like form, hence these pillow-like structures.
In addition to these spectacular pillows, you can see here a collapsed lava tube, where this entire area was like a subway for lava as the molten material traveled from somewhere up the mountain out towards the ocean, and then subsequently collapsed. Ross can only keep his shirt on long enough for 2 takes.
2 take Mitchell.
And then it's got to come off.
Woo! When you look at a stack of lavas, it can often seem like it's a layer cake of perfectly horizontal lava flows. Truth is that volcanic flows come out of volcanoes and flow downhill down a paleo slope. And here's an opportunity to see what we mean when we say paleo slope. Okay, so the water, the ocean here, is our sense of horizontal. Now notice that these layers of lava, these lava flows, are slightly inclined with respect to the horizontal ocean. Okay, just a few degrees, maybe 5, maybe 10 degrees. But that angle is actually telling us something about the viscosity of the lava that makes up these lava flows. Now, what do I mean by viscosity? It's the stiffness of the fluid. A highly viscous fluid being honey, a low viscosity fluid being water. So lava flows with, or paleo slopes with steep slopes are high viscosity lavas, and those with shallow slopes are low viscosity lavas.
And although most of the volcanoes on Iceland are basaltic shield volcanoes, there are also some others with bizarre felsic compositions that form stratovolcanoes. But these rocks are so bizarre, they deserve their own video.